Yes, the code is cheaper now, but the review isn't cheaper. People say they're drowning in PRs. You're not really drowning in PRs. You're probably drowning in bad PRs.
We're going to move right on to the next segment of the show. We're going to bring on Dex from HumanLayer. So we met Dex when we were in YC, and you throw a lot of events in SF. We attended a lot of events that you were part of. You're kind of a big part of, I guess, really promoting a lot of different ideas around AI. And it feels like you're always a few months ahead of, not always, but often a few months ahead of general consensus. If you've been watching the show for a while, you've probably seen a few, we show a few tweets here and there from Dex, when we think he's onto something. So I'm excited that you're finally on the show.
I'm sorry about that, for the record.
And I think the best thing to do, and I didn't tell you this, so it's going to be a surprise. The best thing to do is you have a video. You just launched something. So I want to show the video because I can't introduce you better than the video does. And then we can go on all the other stuff, and we can talk about the video. We can talk about HumanLayer. We can talk about all that.
Sounds great. I've watched it more times than I would be embarrassed to admit the number of times I've watched it. But every time I pull up Twitter, it's somebody talking about it. So it auto plays. Yeah, let's do it. We need to talk about AI code slop.
Codebases are falling apart faster than they ever have before.
With AI, your code kind of gets worse over time pretty materially.
If you keep writing slop, you're going to hit a roadblock.
More volume of code being written, more commits, more stuff being pushed.
Basically, we're in an asymmetric war in slop.
It leads to slop.
And it's not, it's slop.
AI slop.
Coding without really looking at the code and understanding it, it doesn't really work.
Slow the fuck down. Everything's broken.
AI slop.
Slop and garbage.
AI slop.
Slop. Slop.
Slop.
Hi, I'm Dex Horthy, CEO and co-founder of HumanLayer. And in the past year, we've been performing a study into the world of AI coding slop. Today, we are opening access to HumanLayer, an AI IDE, collaboration platform, and building blocks for your software factory. HumanLayer enables engineers solving hard problems in complex code bases to move 2 to 3 times faster across the entire SDLC. You see, at HumanLayer, we've discovered a novel solution to the slop code problem that involves thinking about systems before setting your agent loose. And great engineering teams have actually been doing design reviews for decades. But for a lot of teams, this process is fragmented and manual, stuck in a pre-AI world. We're bringing this missing piece of the software factory, high-level design discussions, to every team. And the results have been incredible. Hundreds of engineers at companies of all sizes are already using HumanLayer to ship faster without sacrificing quality. I'm super excited to invite you to try HumanLayer today at humanlayer.com, and I'm even more excited to see what you build.
HumanLayer is not for everyone. Do not use if you are allergic to reasoning about complex systems. Side effects may include shipping reliable code, clean architecture, and maintainable systems. Stop use and ask a doctor immediately if you see signs of embarrassing your coworkers with how much you're shipping.
Let's make this the year of no more slop.
We need to talk about slop. We need to talk about HumanLayer. We need to talk about looping. I mean, there's a lot we can talk about. Where do you want to start, dude?
I don't know. I'm putting together slides for my World's Fair talk, and I think the thing that I think I've always stood for and always wanted to stand for is cutting through the hype. And there's so much noise around AI of all these things that you should be doing, and everyone's trying to give you FOMO, and it's unclear if it's insecurity or engagement bait or just people are just misled or misguided. But I try to do my best to give people real practical things that actually work, that we've seen work with customers, that we've seen work with users, that I've learned from other people who are way smarter than me, and make that accessible to everybody and level everybody up. Part of that is, I think one of the most important things is we need to identify and defend terms that are useful. I think we've seen year after year in AI, useful terms become completely diffused as they get picked up by the hype train. So we had the word agent, which now means 100 different things to 100 different people. We had the word spec-driven dev that means now 100 different things to 100 different people. We have harness engineering, which was never well defined from the start, because you have kind of the inner harness that the labs build or the agent builders build, and then you have the outer harness that you engineer that is the feedback loops from that like starts to become part of your software factory. So yeah. And then the third thing is like, I want to give people useful stuff that they can go turn around and use and apply in their daily work and that will actually work. You don't need to be able to do reinforcement learning to understand enough about how coding models are trained to apply that knowledge to how you use them. Like I went super deep in the last 2 weeks of like understanding how all this stuff works and how models are trained and how all these coding benchmarks work. And like, I have an undergrad in physics. I am not an AI PhD. Like half the math, I was like sitting there talking to Claude for 10 minutes being like, no, explain this equation to me like I'm a dumbass.
The two terms that I hear frequently from users of Mastra, from people that are building, writing code, developing code, especially building agents, is I want to build a software factory or I need to automate my SDLC. They mean roughly, similar things. Tell us what your experience has been with that. Happy to share what we're seeing, but
that's the next word that's going to get destroyed.
Oh, it's already happening. It's almost too late.
Yeah, there's no going back.
I'm gonna share in the chat a whiteboard link. Are you guys down to do it?
Or you can just share a screen if you want.
Okay, so we've had software factories actually since like I think it was like 1968. There was some NATO thing that defined like, okay, it's not just writing the code, but it's like this thing that builds the thing that builds the thing. And I think like the simplest software factory, and we can start like pre-AI, is you have like stuff to do. This is your like linear, your Jira, your state machine, your issue tracker, whatever it is. You need some kind of thing that like tracks the work. And into this goes input from engineers, from PMs, from like, your CEO / vision for the company, whatever it is. You put it in this list of things. And then maybe you might have some like human process, like you have a, architecture planning, and maybe you have like a sprint planning. I mean, this is like, I always think of like, okay, what do we do with AI and how do we map it onto the meetings that make engineers miserable? And how do we get AI to help with those things? But then you have some step where like someone builds the thing. And in here, you might have, testing that happens locally. You may have like manual testing to like check if it works, maybe in a browser. And then at some point, you go and you create what we call a pull request, merge request, whatever it is. You want some human reviews the change. You probably have like a PM or a QA or an engineer. Some human actually like tests it. Someone else makes sure that it works and signs off on it or whatever. You obviously have a bunch of like CI/CD checks, like unit testing. You might have like static scanning, security scanning, all this kind of stuff. Anything you can automate, etc. And then once all those things pass, then you put it in production, and then your users use it, and then the users talk to talk to people at your company. You get support tickets, you get feature requests. If you're really fancy, you also have like monitoring. So something crashes and you get an alert from Sentry, and that goes to your team as well. And then that becomes more stuff to do. This is like the most abstract software factory. Forget about AI. And then there's already loops in here, right? So this whole outer thing is a loop, feedback, support. And then you have sort of like inner loops here, right? Like, okay, human reviews the change and doesn't like it. Okay, well, that's a loop. You give it back to the person who's building it, and you have them go make the change, and then they test it, and then they do the new pull request, and you run this whole thing again until it gets approved, right? Does it make sense so far?
Yep.
Yeah, I'm tracking. You got the basics.
Okay, cool. So we're gonna take the most naive software factory. This is like when the ramp inspect thing came out in like November or December. Like the primary thing they had done was they removed this like someone builds the thing to like agent builds the thing. And this is pretty, there's a lot going on in this box because you have, you need orchestration to like kick this off and make it when the work is ready to actually go like launch it. You need some kind of sandboxing to run the coding agent in. You need an inner harness, which is like your Claude Code or your Codex. You need an LLM, which is actually doing the coding. Maybe you need like feedback tools, like you need a VM to run it in, you need a browser, et cetera, et cetera. And then the first thing that we brought in was agentic code review. Because the problem is like when you have agents building the thing, this step goes from, 2 days to like 2 hours, maybe. Roughly, let's say, or, it goes from 2 hours to 2 minutes, let's say.
Yeah.
We'll do it that way. 2 hours goes down to like 2 minutes to do like a small change. And so you suddenly have changed your backlog of stuff to do into a backlog of things to review. And so it's like, okay, cool. Can we do agentic code review?
Yeah, the bottleneck moved.
Yep. And if you're really fancy, you have agentic testing where you have like browser use pointed at your PR, or you have it happening here in your sandbox environment as well. You know, agentic, I'll call it manual testing because it's like black box from the outside, but it's technically done by a machine. And then humans can test. You might still do all these other things, right? You have humans testing the change. You might have humans reviewing the code, but they're like more confident, right? Because you've done more stuff to like raise the floor. You've gotten rid of most of the low hanging things. And so maybe you're going faster through your pull requests. And then the next thing people tend to add is like some kind of like agentic feedback loop where you actually like take these feedback and support, and rather than sending them to a human, you just put them straight in the tracker and an agent picks them up and like starts working on them. And same thing for your like monitoring stuff. Instead of like going through users, you say, okay, cool, we got this error from Sentry. Let's have the agent take a crack at it with nobody like actually looking at it, and then see what comes out the other end. And even if the agent only one-shots like 30% of those, that's 30% of time we didn't even have to think about it. We just came to the PR and reviewed it. And this is where you start to build up your agentic software factory. So this is like loop number 2 is this like outer loop around the whole thing. What's also happened here is we probably like are getting rid of this stuff, right? A lot of people say like, we can just move so fast. We don't need to spend as much time. You know, we don't need to spend 2 hours deciding how we're going to build this thing. We don't need to spend 2 hours breaking down the work. Agents can kind of just do this. So you drop this part, right? It's just like, cool, everything we want to do, let's just go do it. I mean, how does your factory look? Like, what about how you guys ship today? I know, what do you have, like 30 engineers now? What about your process is different from this? What maps onto this?
It looks exactly like that.
You just drew it. I mean, the rough tenets of it.
We still do planning though, because I think if without it, that's where the poison starts leaking in.
What is the benefit of planning?
So we don't do sprint planning anymore. We do like goal planning, which is like, what do we want to achieve? And people are working in their own armies of one, right? So they're with their agent and they're just having human level goals. Like, I'm trying to achieve this shit by Friday. Then they get into the factory. But the architecture planning.
And is that a feature shipped?
Yeah, so it's either feature shipped, milestone achieved, which could be something we agreed upon, customer impact achieved, things like that.
Okay, cool. And you mentioned you still do the like architecture planning as well. Yeah.
We don't do a ceremony around it. We just expect that it happens. And when it doesn't happen, things go wrong.
For the person who skipped it or for everybody else?
Everybody.
Yeah, I would say the ceremonies have decreased a bit. Less like ceremonial meetings, but the planning still has to happen. Otherwise, we have seen this. There have been we've dialed things up, turn things up, turn things back, as we've kind of realized that if you take your eye off the ball a little bit, as you said, like Slop can start to, fester. And then once it starts to fester, people know less about that area of the code base. It seems to grow.
Yep. That makes sense. Do you guys review the code? Does every PR at least get a glance? How often do humans come in on PRs and actually change the like program design?
Quite often. So what would happen is like in things that were led astray from the beginning where the context wasn't good, then people who know what to do come in, but they're not manually writing reviews. They're leveraging their context and their agent to do a specific review. This is outside of a CodeRabbit or a greptile. Like this is a human and their agent issuing the review.
Yeah, I would say like AI-assisted human review.
And these reviews, I would say, are a little brutal. Not brutal in the sense they're kind of mean when you get one of them. That means you fucked up.
And it's, I know when I comment on your PR, I'm really just talking to your agent anyways. So I don't have to be nice in it because you're just going to paste it into Claude, right?
Yeah.
Cool. Yeah. I think the next definition that is worth looking at is like, what do we call like the lights off software factory, which is basically where you get rid of all of this, right? You say, okay, we have CI/CD, we have agents testing it, and we have static scanning, and we have security checks. We're just going to stop reading the code. And humans are basically only going to interface at this level of like, we're going to decide what needs to be built. We may do a little bit of triage on user issues, but at the end of the day, like, it is a closed loop. When people complain, the stuff gets fixed and nobody has to think about it. It's an incredible dream. It's an incredible vision. And basically what we've found, we did this. We built this in like September of 2025. So almost 9 months ago. And what we found was after about 3 to 6 months, which I think a lot of people find, is if you skip this review step or you start half-assing your reviews and you're just like, yeah, this is sloppy, but we're just going to let the agent cook. your code base just goes to shit over time. And I'm not going to go into the details of like my thesis on the underlying mechanism, but like the TLDR is all of the ways that we benchmark models on coding. And as far as I can tell, I'm not, I don't have secret contacts inside the labs, but as far as I can tell, almost everything we do for agentic coding, let me see if I can find this. Here we go. Yeah, so here's SWE-bench multilingual. There's some problem statement, and there's like a golden patch, which is the right answer. And then there's like a patch to the tests. So when the agent goes and makes the change, if it changed any tests, we throw out the changes to the tests. We put this patch into the test instead, and then we run it. We run the like golden tests against the agent's change, and we see if it passed. And the problem is like, what makes these good is they're all little like one shot, small, contained. If you can solve 1,000 of these versus, 1,100, that's good signal that like that model might be a little bit better at coding than another model. But nowhere in here in the like verification loop are we able to punish the model for bad code design. Its only job is like, can you get the test to pass? And so when you do reinforcement learning, right? So you have a verifier, which is like, did the test pass? And you pass that in, and then the model has like, you have like a rollout, which is like a certain version. And then it goes and it like does a bunch of inference. It does like this long agentic trace. Do the test pass, and then we do a rollout, and then we do the inference of like, okay, we do this long like agentic trace. You have like a ton of like messages and tool calls, etc. I don't know how we draw context windows. We keep updating it. And actually like Calvin French Owen has a really good, I'm going to switch to one more tab. This is a really good slide. So you have the agent go through and it like tries to do this thing a couple different times. And sometimes it does a search and NPM test. And it's like, okay, if it's correct, we get a point. If it's concise, if it passed the test. So yeah, we do a bunch of runs and then it all gets like strung through and then we like evaluate at the end. And you might just see, did the test pass? You might have other things like, was it correct? Was it concise? You penalize it for like running the test too many times, whatever it is. And then at the end of the run, then you like change the weights of like, okay, every decision that was made here, make that a little bit less likely. Every decision that was made in like the positive ones, make that a little bit more likely. The one that spent too much time, penalize it a little bit. And you do this over and over again for months and months and months on thousands and thousands of problems. And eventually you get out a model that's like better at coding. The take is basically, if you build this lights off software factory, you don't have any training in the models that makes it better at like, because the penalty is just, did the test fail? There's no penalty for like, did an engineer working in this code base 6 months later find it incredibly hard to keep making changes to it? And every time you change something over here, it breaks something over there. That's kind of my like definition of bad code quality. And it's really, really hard to teach models how to like to penalize models for writing sloppy code in that dimension. So that's kind of our take is like, don't sacrifice the architecture planning, don't sacrifice the sprint planning, and don't sacrifice the code review. Yeah. And basically like these three things together give you actually like a really good software factory in the sense of like, okay, cool. I can either review this PR for 6 hours, version 1, and not do any of this, or I can like basically like look at the like think about how we're going to do it and align with a model on how we're going to do it so that like we maximize the chance that this code review is only like 20 minutes or 5 minutes or whatever it is. And so it's all about leverage. Is if you can re-steer early in the process before you've done all the building and sandboxing and testing and all this stuff, before the model's already committed to a direction, then you can increase the probability that when this PR comes out, it's 95%, 99% perfect. And that's what we're building at HumanLayer. It's like, how do we do this collaboratively on teams? How do we make sure that we can move a lot faster without sacrificing quality and without sacrificing like humans still owning the outcomes? That's it.
That's dope. I actually I quoted you during our all hands this week. I really resonated with it. If you feel like PR review, code review is the bottleneck in your system, figure out how to increase the odds that the code is 95% or 99% correct by the time it gets to review. That's classic line. I love it. Is that more so that we need to plan better? We need to architect and design better. That is the only way to get there, right?
I think so. I mean, obviously, like anything you can do with deterministic linters is great. Anything you can do with agentic code review is great. But I think if that's your only plan, then your code base is going to devolve pretty materially over time. And as engineering teams, like this is why we have architecture and review and sprint planning is like, hey, let's align on how we're going to do this before someone spends 6 hours writing the code. And yes, the code is cheaper now, but the review isn't cheaper. And so it's like, okay, cool. The more likely people say they're drowning in PRs. The other bit I'd like to do is like, you're not really drowning in PRs. You're probably drowning in bad PRs, because even a PR that is like only needs 20% rework, like it's actually kind of close. And that's generous. If you just YOLO prompts to an AI, your PR is on average probably going to need about 50% rework, depending on what you're building and how long it needs to last. And so it's like, okay, cool. So actually a perfect PR, or like a within 5% PR where you're just like, oh, can we like twiddle these variable names or whatever it is? It's actually not that bad. It's a joy to review a really good PR. It's beautiful.
It just seems to me, especially, you mentioned the benchmarks. I feel like there needs to be a multi-step benchmarks that validate, the fifth or sixth task in a list, that should be faster. And, almost like if the model takes longer on that fifth task, it's probably because the first 4 tasks that might have passed, the code was shit, right? And so I feel like there needs to be these like longer horizon benchmarks.
Yeah, we're working on a benchmark harness. It's kind of based on Harbor, but it's a Harbor adapter where you actually like have a model. It doesn't know what the roadmap is in advance, and you've actually like stacked up about 20 feature requests for this product that is. It's not just like rebuild GitHub, because GitHub's really already in the weights and it can kind of guess what features are coming. But if you can pick something that's a little weird or off training set and have it basically build 20 features in a row, and one, penalize it if it fails on any incremental feature. But then also, if let's say an Opus grade model gets to issue 20, and then you hand issue 21 to Sonnet or even Haiku, and you see, can a smaller, dumber model solve an issue in the code base that this model has been like persistently working in? You get you get an amplification of signal of like how good is the code quality, because a smaller, dumber model is not going to be as adept at working in a messy code base.
Yeah, those are the types of things we need. And I feel like people are obviously thinking about it. I didn't know you were. That's good. But without that, I don't think the model weights are ever going to get improved to fix this problem of not slowly letting slop creep in and kind of, because that's not the goal. The goal is, did the test pass? Did I complete the task as designed? Not did I introduce technical debt that is going to impact the team or other agents in the future.
Shameless plug, if you are interested in RLVR and working on models that are better at code quality, we are hiring. Founders at humanlayer.dev, shoot us a note. If you want to try our product, humanlayer.com. We have free for up to 3 people, so it's designed for small teams to kind of play with it, feel like you're shipping way faster. We have like larger, more sophisticated team plans. But this has been really fun, guys. Thanks for having me on.
Thanks for coming on.
Yeah, we appreciate you coming on. Appreciate you spreading some wisdom.
This was super fun, guys. Thank you.
Every week in AI, something insane happens.
And there's so much drama. Every Monday, we break it down live.
We do the news, we bring on guests building in the space.
And we go deep into the stuff that actually matters.
Agents Hour, every Monday, noon Pacific.
Follow. Don't miss it.
Peace.